Next, we are going to try to graph this rational function. Again, rational function look like a fraction, and this is a review, and we are showing you a question that was an old final exam question. So we were talking about what we need for graphing rational function. We need two things, and the two things are what? The two things are you need intercept, which include x-intercepts and y-intercepts, and you also need asymptotes. So let's find x and y-intercept first. To find x-intercept, we're going to set y equal to 0, right? And if you're really smart, you know 0 equal to a fraction mean the top part of the fraction equal to 0. But if you forget about that, or if you don't know about that, you put 0 equal to a fraction. In order to solve for that, you're going to need to multiply both sides with the LCD, which is x plus 2. And if you do that to both sides, then the left-hand side, 0 multiplied to anything is going to be still 0, and the right hand side is going to get rid of the denominator, so you have 8x minus 1. So either way, you should end up with that. You need to solve for x, so you're going to add 1 to both sides. You have 1 equal to 8x, and divide both sides by 8. So you should get x equal to 1/8. That's your x-intercepts. And to find y-intercepts, we are going to set x equal to 0. So to find y-intercept, we're going to set x equal to 0. So we get y equal to 8 times 0 is 0. And then you need to subtract 1, and then you have 0 plus 2. So you're only plugging in 0 for x. Alright. So the top part, you have 0 minus 1. Bottom part, you have 0 plus 2, so y equal to negative 1/2. That's your y-intercept part. And if you want to write this as points, for the x-intercept, it's going to be 1/8 and 0 because you plug in y equal to 0, right? And for the y-intercept, you plug in x equal to 0, so it'll be 0, negative 1/2. So those two would be your x and y-intercepts. And the next part, we are going to find asymptotes. So for asymptotes, we have vertical asymptotes. Vertical asymptotes, basically just setting the bottom part equal to 0, finding what the restriction for domain, so x plus 2 equal to 0. Let me write down for you. You set the bottom part equal to 0. And to solve for x plus 2 equal to 0, you subtract 2 for both sides, so it's going to be x equal to negative 2. And don't forget, vertical asymptotes is a vertical line, so it needs to be x equal to a number. And when you have only one vertical asymptote, and it's going to tell you how many pieces of graph, right? It means you're going to have 2 pieces of graph. Alright, so horizontal asymptote, so if you are not sure what I'm talking about, I can sketch it for you real quick. So if you have a graph with only one vertical asymptote here, it means you will have one piece on the left and one piece on the right. So one vertical asymptote, 2 pieces of graph. The second part would be horizontal asymptotes. So let's see if this one have a horizontal asymptotes. If your question is your function equal to 8x minus 1x plus 2, the highest power, both top and bottom, is going to be degree 1, right? So I just need those coefficients. So this is 8, this is 1x, right? So y equal to 8 over 1, basically y equal to 8 is my horizontal asymptotes. This is vertical asymptotes. So one vertical, one horizontal. And when you have a horizontal one, it means you don't have slant, right? Because slant asymptote need to be the top is exactly 1 degree higher than the bottom one. With all this information, we can try the graph. So I don't have a really big screen, so you're going to have to just look at this. All right, let's try. We are going to put the asymptotes here, so 1 and -2 about here, telling me I have 2 pieces of graph, x equal to -2, and then I have a horizontal asymptote, 1, 2, 3, 4, 5, 6, 7, 8, ooh, it's like way up here, sorry. Not very good plan. And then maybe let me put it on another piece of paper because you're not going to be able to see it very well. So if I'm putting it on this piece of paper to graph this. So earlier we already found that x-intercept is 180, and then the y-intercept is 0, -1/2, and you have a vertical asymptote of x equal to -2 and a horizontal asymptote of y equal to 8. So we're going to try to graph this with more space here. So vertical asymptote 1 and 2, x equal to -2, 2 pieces of graph, 1, 2, 3, 4, 5, 6, 7, 8. Horizontal asymptotes, y equal to 8. And then I also have some intercept, which is x equal to 1/8, very close to 0. And then y equal to -1/2, very close to 0 again. So which means my graph have to go through this point and this point. So on the left, when we need to decide if the graph is on top or the bottom, I'm pretty sure it's going to be at the bottom, right? Because I have to go through these two. And remember, the graph has to be function, which means that it need to pass the vertical line test, and the graph also what? Get close to the asymptotes, right? So I'm going to get close to the asymptotes and try to make it smooth, get close to the asymptotes for one piece. So the other piece I need to decide is on top or bottom. If you're really smart, you should be able to explain that it's going to be on top, and the reason is if you only have one x-intercept and it's here, and you're not going to have any x-intercept here, meaning you're not going to cause these parts, then your graph have to be on top. But if you don't realize this, what you can do is you can test a point in this area, which is smaller than x equal to -2. You can say let's test x equal to -3 and plug in my original functions, which is this, right? And when you plug it in, you have y equal to 8 times -3 minus 1 and -3 plus 2. So on top, you're going to have -24 minus 1. At the bottom, you have -1, right? Which will give you -25 over -1 is 25. So the points you get here is x equal to -3 and y equal to 25, right? Which means the point is going to land up here when you have -3 for x. I'm sorry, this is positive 25. So when you have -3 for x, your y is positive 25. So it's going to be get close to the asymptote, something like that. So that would be your graph. So to kind of recap what we just did, to graph rational function, we need to find the intercept, which is x and y intercepts. We need asymptotes. We have vertical, horizontal asymptotes for these particular questions. Sometimes you may need to test point to get additional information for the graph.